Section 3.4, Measures of Position. The objectives of this section is we want to determine and interpret Z-scores, determine and interpret percentiles, determine and interpret quartiles, and check its set of data for outliers. Now, in section 3.1, we determine the measures of central tendency, which describe the typical data value. In section 3.2, we discuss measures of dispersion, which describe the amount of spread in a set of data. Now, in this section, we discuss measures of position, which describe the relative position of a certain data value with the entire set of data. We end this section with introducing a method that allows us to check a set of data for outliers. Now, for the first objective, objective 1, we want to be able to determine and interpret Z-scores. Okay, so for the 2016 baseball season, the Boston Red Sox led the American League with 878 runs scored, whereas the Colorado Rockies led the National League with 845 runs scored. It appears that the Red Sox were the better run-producing team. However, this comparison is unfair because the teams play in different leagues. The Red Sox play in the American League where the designated hitter bats for the pitcher, whereas the Rockies play in the National League where the pitcher must bat. Pitchers are typically poor hitters. To compare the teams' runs scored, we must determine their relative standings within their respective leagues. We can do this using a Z-score. Now, the Z-score represents the distance that a data value is from the mean in terms of the number of standard deviations. We find it by subtracting the mean from the data value and dividing this result by the standard deviation. So here is the population Z-score, where Z is going to equal the data value of X minus the population mean over the population standard deviation. Or if you're using the sample Z-score, the Z-score is going to equal the data value minus the sample mean divided by the sample standard deviation. Now, the Z-score is unitless. However, it has a mean of 0 and a standard deviation of 1. Now, if a data value is larger than the mean, the Z-score is positive. If a data value is smaller than the mean, the Z-score is negative. If the data value equals the mean, the Z-score is 0. A Z-score measures the number of standard deviations an observation is above or below the mean. So, for example, a Z-score of 1.24 means the data value is 1.24 standard deviations above the mean. A Z-score of negative 2.31 means the data value is 2.31 standard deviations below the mean. Now, make note here that we round Z-scores to the nearest hundredth. So let's take a look at this example here. Okay, we want to determine and interpret Z-scores for this example. It says determine whether the Boston Red Sox or the Colorado Rockies had a relatively better run-producing season. The Red Sox scored 878 runs and play in the American League, where the mean number of runs scored was mu, which is equal to 731.3, and the standard deviation was 54.9 runs. The Rockies scored 845 runs and play in the National League, where the mean number of runs scored was 718.3, and the standard deviation was 61.7 runs. Now, the word relatively suggests that we are comparing two data sets. Therefore, compute each team's Z-score. The team with the higher Z-score had the better season. Because we know the values of the population parameters, we're going to compute the population Z-score. Okay, so let's go ahead and first find the Red Sox Z-score. So we're looking at the Red Sox. So we're looking for the Boston Red Sox. And they scored 878 runs. They had a population mean of 731.3 and a population standard deviation of 54.9 runs. So now let's find the Red Sox Z-Score. Okay, so what is the information that we need to know? Well, we know that the data value, x, is going to equal 878. Okay, we also know that the population mean is 731.3, and we know that the population standard deviation is 54.9 runs. Okay, now keep in mind here, so we're going to call this Z-score, and I'm going to put RS here for the Red Sox. Okay, and so recall that the formula is the data value x minus the population mean divided by the population standard deviation. So that means we're going to take 878 and we're going to subtract 731.3, which is the population mean, and then divide it by the population standard deviation. Okay, so what do we get here? Well, let's go ahead and do this in our calculator. Okay, so we have 878 minus 731.3, and then we're going to divide that by 54.9. Okay, now, so here we're going to round this to 2 decimal places, because remember, we round z-scores to the nearest hundredth, so we're going to round this to 2.67. So therefore, this gives us 2.67. Okay, now what we want to do is we want to find the Colorado Rockies z-score. Okay, so when we're looking at the Colorado Rockies, right, we know that the Rockies scored 845 runs. We know that the population mean for the National League is 718.3 and the population standard deviation is 61.7. So we know that X, which is the data value, is 845 runs. We know the population mean for the National League is 718.3. And we know the population standard deviation is 61.7. So let's find the z-score for the Colorado Rockies. So again, the formula is taking the data value minus the population mean over the population standard deviation. So we have 845 runs. We're going to subtract the population mean of 718.3. And then we're going to divide that by 61.7. Okay, so let's go ahead and do this on our calculator. So we have 845 minus 718.3. And then we're going to divide that by 61.7. And that gives us 2.053. We're going to round this to the hundredth place. So it's going to be 2.05. Okay, so now that we've found the z-scores for those two, so the Red Sox had a run production of 2.65 standard deviations above the mean, whereas the Rockies had a run production of 2.05 standard deviations above the mean. Therefore, the Red Sox had a relatively better year at scoring runs than did the Rockies. Okay, now we want to interpreting negative z-scores. Okay, now the previous example dealt with positive z-scores. With negative z-scores, we need to be careful when deciding the better outcome. So for example, suppose Bob and Mary ran a marathon. Bob finished the marathon in 213 minutes, where the mean finishing time among all men was 241 minutes, with a standard deviation of 57 minutes. Mary finished the marathon in 239 minutes, where the mean finishing time among all women was 273 minutes, with a standard deviation of 52 minutes. Okay, so the question is, who did better in the race? Okay, so let's first talk about these two. So we're going to have Bob. So we're going to look for Bob's z-score. Okay, and so what do we know about Bob's z-score? Well, we need to know that the value of x for Bob finished with 213 minutes. So that represents the data value for Bob. And then we saw that the mean for all men was 241 minutes. So that means the population mean was 241 minutes. And then we saw that the standard deviation was 57 minutes. Okay, so in order to find the z-score for Bob, we're going to take the data value of x minus the population mean and divide it by the population standard deviation. So we have 213 minus 241, and then we're going to divide that by 57. So let's go ahead and figure what that's going to give us on their calculator. So we have 213 minus 241, and then we're going to divide that by 57, and that gives us negative 0.491. We're going to round it to 2 decimal places, so that's negative 0.49. So this gives us negative 0.49. Okay, and so now what we're going to do is now we want to be able to then find the Mary's z-score. So let's find Mary's z-score. Okay, so Mary's z-score so she finished the marathon in 239 minutes. So that means that her data value is 239 minutes. Okay, the mean for time for all women was 273. So that means that the population mean for women was 273. And then the population standard deviation is 52 minutes. So let's find the z-score for Mary. Again, we know the formula is the data value x minus the population mean over the population standard deviation. So we know her score was 239. We're going to subtract the mean of 273, and then we're going to divide that by the population standard deviation of 52. So let's go ahead and do that. So we have 239 minus 273, and then we're going to divide that by 52, and then we're going to round this to 2 decimal places. And this is negative 0.65. So this gives us negative 0.65. Therefore, we can say that Mary did relatively better. Even though Bob's z-score is larger, Mary did better because her time is more standard deviations below the mean.